Okay, so dear students, now we are computing the IRR, right? IRR, which is internal rate of return. As I've explained, what is the internal rate of return? The interest rate, right? What I put it here instead of this IRR, and when I compute all the present value of all these cash flows, right, to give me back this initial cash outflow, as I have explained in a previous example, right? So what is the interest rate, right? What is the discounting rate? What I just put it here and discount all these future cash flows, right, by that rate, and to give me exactly 40,000. So let me explain it. For example, here I just put this data in this equation. So how much is our ICU here? The initial cash outflow, that is 40,000, right? So I just write 40,000, and this is equal to CF1 means cash flow in the first year. So the cash flow in the first year, that is 10,000, right? Okay, so 10,000, and that is to be divided by 1 plus IRR. This is IRR means internal rate of return. This is the discount rate, right? What I don't know about it now. Okay, and this is after 1 year. After 1 year. Okay, then plus the second value, the cash flow CF2, that is we have that is 12,000, right? Okay, so 12,000, this is CF2 divided on 1 plus IRR raised into power 2, okay, in this way. Okay, and then the third value we have, that is 15,000. Okay, 15,000 divided by 1 plus IRR raised into power 3. Okay, and then the fourth value, that is 10,000. Okay, and divided on, we have 1 plus IRR raised into power 4. Okay, in the last value we have okay, and the last value plus, and that is 7,000 divided by 1 plus IRR raised into power 5. Okay, dear students, now the question here is what is the interest rate if I just put it here and discount all these future cash flow and to give me $40,000. This is not 4,000. This is 40,000. Okay, so this 40,000, this is our ICO, initial cash outflow. Okay, so it is really difficult just to do the math and find out this IRR value. What is the rate that equate all these future cash flows, right? The present value of all the cash flows with this initial cash outflow. So dear students, we are using the method of interpolation. Okay, so which method is used? Interpolation. Okay, in this method we have some steps. Okay, the first step, we have step number 1, we have to find out discount rate which equates the which gives the present value of future cash flows either higher or lower. Okay, in the first step, try to just put here interest rate which give you the present value which is either higher than 40,000 or lower. So in our question, I try to find out the value which is higher, right, or maybe lower. So any value you can try it here. Just when you try it, at the end you will just check whether the computed value will come either higher or lower. So let me try 10%. Okay, so what I'm just doing here, we are trying 10%. So let's try 15%, yeah, or 10%. Okay, I'm just trying 10%. Instead of IRR, I'm just putting 10%, and then I see what is the future value, the present value of all these cash flows is. Okay, so look, in the first 10%, I'm just using this function. Okay, so you can say the present value of all these cash flow are present value using the lower interest rate equals sign. We have 40,000, sorry, we start from 10,000. Okay, so 10,000, the first value, this is 10,000. Here we have another 0. Okay, so 10,000. Okay, then divided by 1 plus, I use 10% rate. Okay, 10% raised into power 1. Okay, then plus 12,000 divided by 1 plus 10% raised into power 2. Okay, and then we have 15,000 divided by 1 plus 10%, okay, make it percent, 10% raised into power 3, raised into power 3. Okay, dear student, make sure these are percentages. Okay, so percent here, okay, and 10%. Okay, then we have plus 10,000 again divided by 1 plus 10% raised into power 4, and then plus 7,000 divided by 1 plus 10% raised into power 5. Okay, dear students, the same equation I'm just using here. So look, 10,000 divided by 1 plus 10 raised to the power 2, and raised to the power 2 here, and 3, and 4, and 5. Make sure all these values are correct. Okay, now you can do so and just press enter, and the value we found, and that is 41,000, and you can say, and this value is somehow value is higher. Okay, so this is present value using one interest rate, and this is 10%, and by using the 10% interest rate, look, dear students, the computed value is higher than the 40,000, and this is the first step. A step is to find out the discount rate which gives the present value of future cash flows either higher or lower. So you can say we found 10%, so the 10% is giving us the present value computed from this project, and that is higher than the initial cash outflow, which is 40,000. Okay, now the lower value you tried and is giving you what, the higher value of present value, high comparatively to this one. Now try one another percentage, one another discount rate which to give you the present value lower than $40,000. So obviously, dear students, you have to increase this 10%. Why? Because when you increase the value in the denominator, then what happens? The result will decrease. Okay, so if it is 10%, by the 10% it is giving 41,000. So obviously, if you increase it, then the present value will become lower. Okay, so the more you expect to get this value lower, then you have to increase the interest rate. So in the second step, so this is step first. Okay, this is first step. Now in the second step, what you need to do, okay, find what we have here. Yes, let's try 15%. Okay, so this is step number 2. Okay, step number 1, and step number 1 we tried 10%, and the step number 2 you should try obviously the discount rate, which to give you lower value. You should not decrease it 10%, you should not decrease it from 10%. Why? Because it will give you even higher value, but we need to get this value lower. Then what you have to do, you have to try a higher discount rate, a higher percent. Okay, so now I'm just trying to put instead of the IRR another value of 15%. So I'm just copying this formula here. Okay, so this is, you can say, the present value 1, and now we use the present value 2 with the another rate. Okay, so just copy this formula and put it, and I'm only changing the rate here, and this is 10%, I make it 15%, and here just make it 15 and 15, and here also 15. Okay, and now press enter. So look, dear students, this value, the second value we found, this is lower. So the first value, this one is higher, right? This is higher value. Okay, we found a higher value. This is our higher value, right? And this is lower value. Okay, now dear students, and we achieved our goal. And what was the goal? You should try one interest rate or the discount rate which should give you the present value computed higher than the initial cash outflow, and then you have to try one another rate, right, which to give you a present value computed lower than this. Okay, so keep in mind, if you tried 1% which is giving you higher value, then you have to increase the discount rate, right? Why? Because that will give you another value of lower. And then keep in mind, you have to just keep a distance between these two interest rate or discounting rate. Okay, so for example, if you have selected one value of 10%, try to select one value with sufficient distance, and you need not to give 11%. Why? Because if you try 11%, maybe it will come some have around 41,000, maybe equal a little higher or a little lower. So in order to make it sure, try to just give another value with a little bit distance. So you can try 10% and 20%, 10% and 25%, 10% and 30%, whatever, but try to make sure the value, the second value, is computing the present value lower than the first one, or lower than the initial cash outflow. Okay, so these two values are not these two values must not be always same. For example, as I have just given 10% here, so you can try 5%, and here you can try 20%, you can try 9%, here you can try 15%, right? So only you try to find out two discount rates or percentages which gives you one value higher than 40,000 and another value lower than 40,000. Okay, now in the interpolation method, what you have to do, look, dear students. Okay, if in order to interpolate, you should try first lower interest rate here. So how much is a lower interest rate? That is 10%. Okay, so I just mentioned here that is lower interest rate is 10%. Okay, then we have IRR. Okay, why? Because between the lower and the higher percentage discount rate, what we try to find out is IRR, and then the higher percent or discount rate, what is here is, so this is the lower one, right, and this is the higher discount rate. Okay, so the higher one is 15%. Okay, this is our 15%. So now, dear students, you have to write it in this way, in a column: 10% IRR and 15%, and then you have to find out the difference between these two. So what is the difference between 10% and IRR? The difference is the difference is X. So we don't know how much is the difference between these two. And what is the difference between these two, right? The difference between the 10% and 15%, that is 0.05, right? Or you can say 5%. If we convert it into divided by 100, then that is equal to 0.05. Okay, so dear students, the value we computed by 10%, how much we have found with 10%, and that is 45454, right? 0.57. Okay, and the value of IRR, what we need to find out, that is 40,000. Okay, the IRR is the discount rate, which will give us exactly 40,000. In the value we found with 15%, that is 36,829.89. Okay, now you need to find out how much is the difference between these two values, right? And then how much is the difference between these two. So let me find out the difference between 40,000. So the difference, you can find it here like equal sign from this value you have to minus 40,000. So the difference is 1454.57. Okay, now how much is the difference between these two values? Okay, these two values, it's been between 41,454 and 30,829.8. so that is, you need to find out. Okay, so equal sign from this value you have to minus 36,000, right, this value. So this is 36,000. Okay, and that is equal to 4,624.68. So dear students, look here, this method, if we try to do this method, this is called interpolation. Okay, so now what we do right now here, we are just making an equation, and by the help of the equation, then we find out the x value, and when we find the x value, then we can find out the IRR value. So look here, dear students, you have to divide x over 0.05. Okay, so you can say x divided by this value 0.05, okay, equal to this value 14,000 1,000, this is how much, 1454.57 So 54.57, that should be divided by this value, 4624. So 4624 24.8. Okay, so dear students, look here. So from this equation, whenever the difference between the discount rates, so look, this is the difference between these two discount rates, and the difference between, so the difference between the, so the ratio of the difference between the discount rates must equal to the ratio of the present value computed by those discount rates. So this is the logic behind. Look, once again, I'm just telling you, the ratio of the differences between these discount rate must equal to the ratio of the present values, or the values computed by the help of these discount rates. Okay, so this is the ratio of the difference between the discount rate, and this is the ratio of the differences between the present value computed by those discount. So now I have a question here. We need to find out x. Okay, so just do the cross multiplication and find out x. So the x is equal to how much? Okay, 0.05. okay, and into 4.57. okay, okay, divide this on what, 4 6 2 4.8. Okay, dear students, now we can get the x value. So how much is the x value? Look here. So the value we found here, that is, if you compute this one, so we have 0.0.015 73. Okay, so dear students, this is the value of x. Now when you find this value of x here, it means the difference between IRR and 10% is x. It means IRR minus 10% is equal to x, or you can also say IRR is equal to x plus 10%, right? So you can say we have a formula like this one, IRR. Okay, this is equal to, when the difference is x, it means when you add with this IRR, right, IRR is equal to when you add 10% with x. So you can say 10%, right, with x plus x. How much is x? The x value, this is 0.01573, or if you just convert it into multiply it with 10%, then this is equal to how much? This is equal to 1.573%. okay, if you convert it into percent. Okay, multiply this with 100 is equal to 1.573%, and then when you edit, so finally we have IRR equal to how much? 11.11. This is okay, this is point, okay, keep in mind this is point. So 11.573%. This is called IRR. What does this mean, dear students? It means if you put 11.53%, right, in this formula, in the formula, like if here, if you put this 11.573% instead of this IRR value, right, if in our example, so this will exactly give you how much? 40,000. So you can say the rate of this project, the internal rate of return here in this project is how much? That is 11.5, the IRR, this is equal to 11.573%. okay, this is what is called the project rate, or internal rate of return. It means the future cash flow which is coming to in these 5 years by which rate? By 11.57%. okay, so dear students, if your requirement, or if your required return, how much you require from this project, the project is giving you simply 11.57%, right? But how much you are expecting from this project? For example, if your expectation of the project is 13%, how much? 13%. It means you say that if this project is giving me internally how much return? 13%, then this project is acceptable for me. Or if the project is not giving me 13% or lower, then it is not accepted. So you can say the acceptance criterion. What is the acceptance criteria? The acceptance criterion for this project is equal to if the IRR is greater, right, or equal to required return, then what do you have to do? Accept the project investment, or here is the project investment, say. And also you can say if the IRR is lower than the required return, then reject the project. In simple word, dear students, how much is the required return in this example? 13%. And how much is IRR? That is less than the required return. So if the IRR computed, or the internal rate of the project is greater than that situation, the project should be accepted. It means the investment should be made here. This is good for based on your required return. Okay. But if the IRR is lower than the required return, as it is here in this situation, then in that situation you have to reject the project. It means you should not make investment in this project. Okay. So dear students, you have learned the manual method of interpolation, that have to interpolate in order to find out this IRR value in this example. But keep in mind, dear students, to make it very much simple, this is only the process. This was only the process behind the scene you have learned, that have to compute the IRR. But in Excel you can compute this IRR directly with using the IRR function. For example, I'm just using the IRR function in Excel. IRR using Excel function, right? And then we have a formula here, the function we have in Excel for this computation, to find out the same result. So equal sign and just write IRR. Okay, IRR means internal rate of return, and then put the values. Okay, you have to put all these values, including the cash outflow, and then press enter. Now how much is coming? Look, 11%, and just check the decimals here, and that is exactly 11.47, or in our case it is 11.57%, as if we have done it manually, and that is why some decimals we have not taken in our calculation. And here in this computer, the result is directly 11.47. okay. This is the way if you want to use Excel function. So dear students, this was all about IRR, internal rate of return. Inshallah, in next class we will work on another two methods of computing or analyzing the projects, the evaluation methods. We have one is PI, the profitability index, and also the present value, or only the present value method, okay, PV. So I hope, dear students, you have learned about two methods. One is payback period, and the second was IRR, the internal rate of return. In simple words, you can say the rate of the project here we computed, and based on this rate we are comparing it with our required return, right, and then we are making decision about the projects. So have a nice time and good luck.